Welcome to the TaiyangNews and SNEC Solar Leadership Conversations. My name is Michael Schmela and I'm the Managing Director of TaiyangNews, and I have the great pleasure to have with me Dr. Xinwei Niu, who is the Senior Vice President for R&D at JA Solar. Welcome.
Thank you.
So let's talk about R&D. It's important. There's so much news happening in the solar sector. Technology is advancing so quickly, and JA has been always on the forefront of innovations. Tell us a little bit about your R&D culture. So how important is R&D at JA?
Well, the R&D is a crucial or key importance for not only for solar, right, for any manufacturing business. Yeah. We have like a tradition for the innovation because we start our business on the solar cell. Then we migrate to the next stream, to the module. You know, the solar cell is a key part of the module, right? So from that time, we invest a lot of money, effort, people to make the best solar cells. So we established a couple so-called R&D center. Now one in the Hebei called Jiangzhou, is capital of the Hebei province. We have a front like a solar ingot, you know, the ingot, poly ingot, growth and the cutting. We call it wafer business. So our R&D effort for the wafer business in the Hebei, in the Jiangzhou, and the solar cell and the module focus on in the Yangzhou, not far from here, maybe 200 miles. The solar cell and module in Yangzhou. And also some of the storage, hydrogen and application also in Yangzhou, and part of in Shanghai Fengxian we have a manufacturing base, and part of the storage business or storage research R&D is also there. So the R&D for JA Solar is very important because it's keep your competition advantage and bring new technology, generate new technology, also for the new product, because our final product is for the customer, right? So all this is actually for the product. So all the prototyping is also from R&D in JA Solar, not from manufacturing. So we have prototyping and they go to mass production, something like that. So we typical waste around 5%. Well, next year, the previous year, roughly 6% of the revenue sales in R&D.
Wow, that's high. Yeah.
So last year probably $4.6 billion, but not dollar, 4 billion Chinese yuan RMB on R&D. But not totally spent on this part of the R&D, the focus R&D center. Also for manufacturing base, they have our own innovation and continual improvement, and also count as the R&D budget. So the total is around 4.6 billion yuan, something like that. And over this year, we granted like a Chinese patent, also European, American called PCT patent, over 1,200. Most of them on the cell technology, processing technology, material design. Most of them are creation type of patent, not the design patent. Yeah. So it's if you say JA Solar is successful, at the backside is a key backbone in R&D. Okay. So I think it's very important also for the solar business.
Yeah. As you mentioned, the cell is the core of the module actually, and a lot of R&D has to be invested in that. Yeah. So we had a recent Taiyang event where a colleague of yours presented the latest on TOPCon also. At SNEC, as I understand, you're also introducing new products. So can you just tell us a little bit, so what's from R&D flowing into the new products and is being released at SNEC?
Sure, it's a so-called TOPCon, but inside JA Solar it's called Baixian. It's a different name, but almost the core is the same. Actually, we started TOPCon very early. maybe 5 years ago even. It's not a one-day's business. We started with a traditional like a pit N-type wafer, N-type solar cell. That type without a so-called passive contact, just a regular N-type solar cell. Typical the kind of Panda, you remember Panda that time from Yangli, similar but somehow different. Yeah, and then in the 2017, somehow 2018-17, we introduced the so-called passive contacts to the backside. This is just similar, very similar to the TOPCon. So it's we migrated from the simple N-type solar cell to the passive contact N-type solar cell. There's also in industry a similar name called TOPCon, but in solar cell in the solar internal it called Baixian, in Chinese called Beixiu. It doesn't create a marketing name. Not big. So that now in R&D we can our best results, not a single piece, like a batch, is already over the 26.1, 26 something. That's for R&D. And the VOC, the open circuit voltage, the typical can reach 735. That's very high. But this one is already have a selective emitter. The older version can reach 725 something. And also in the mass production, we have a manufacturer base in Hebei, Ningjin, and that one the typical solar cell efficiency over 25, 25.1, 25.2, something like that. And based on this solar cell, and we also build our product based on the TOPCon cell. We call it Deep Blue 4.0, Deep Blue 4. Deep Blue 3 is a PERC. Deep Blue 4 is so-called TOPCon. And typical module efficiency is like over 22 point somehow. And a typical 72-piece module, you can reach 630 watts. That's pretty high. That's maybe 2 or 3 grade higher than the PERC, like 15 watts, 20 watts higher than the PERC. Today we also have a couple examples on the SNEC show. If you have time, have to our showroom in the N2 building.
For sure, I will take a look.
Yeah, it's nice, and this one is the cost is somehow higher in the PERC, but for the end customer, they have a lot of advantage. They save a lot of BOS, so the overall create a lot of benefits for the customer. That's why this one is very shortage for the service.
Is it a glass module or is it?
It's double glass.
Double glass. Okay.
So this encapsulation for the N-type cell is very tight and need a lot of new effort. So typically people do the double glass, don't do the single glass. Single glass one, backside is a polymer, right? It's easy for the water to degrease. So typical TOPCon module normally is a double glass.
Okay. Are you also showing other new products or?
This time we saw 3 categories. One is our butter bread for the as a PERC module. We call it Deep Blue 3, Deep Blue 3.0. And TOPCon is also one new product is based on the heater junction, heat cells. Heater cell, we call it HJT or HIT, whatever you call it. Yeah. Also a module for the back contact module called the BC. Because we use P-type wafer, people also call it the HPBC, but in J Solar, we just call it PBC.
Okay.
Yeah, similar to our friends' product. Yeah. So this is 3 or 4 type products.
And these products are all commercially available. So you're producing. Okay, obviously you're still producing PERC. You have
PERC is,
TOPCon, and what
PERC
about
we have,
HJT
yeah.
and back contact?
PERC we have a lot. Actually, we have a lot in the process to build up the capacity of the TOPCon. For the HIT, we have a pilot line in R&D. That capacity is only 300 megawatt. It's also for do the experiment, not for the commercially. And we build up a factory in Yangzhou at around 2 gigawatt. It's like a pilot test manufacturing. It's already mass production. Because the 2 gig, even 2 gig in the previously is huge. Now 2 big, 2 gigawatt is small. But 5 years ago, 2 gigawatt is large, right?
So that means for the PBC, you still have a pilot plant, and you're just building a
PBC is in the research R&D,
Okay.
R&D stage, and we internally we have a lot of round for tests like pressure test for do the manufacture, do the run, not manufacturing, and then we see the process very stable, or supply chain is okay, and so we can have this product just to test how the market react to this product.
Okay, so it's just
It's not a
commercial product, huh?
If you get order today, we probably don't have. But other sort of product we already have one.
So HJT you can buy today.
You can buy, yeah. You can take order.
Okay.
Yeah, you can maybe Q3, Q4 this year, we can ship it.
You can ship it. Okay.
Yeah. It's already built up the factory, and now you have order for the machine, for equipment, and they will come out regular soon, and so we can. The plan is roughly Q4, early Q4 we can have commercial shipment.
Okay.
But this year maybe only a couple hundred megawatt output, not capacity. But the major capacity is next year.
And then actually, so when you look at the different customers, how are you positioning HJT versus TOPCon? Because efficiencies are probably similar. Maybe HJT is a little bit higher. So how are you positioning it?
Now the TOPCon get popular because it's quickly replace the PERC.
Yeah.
Now because the investment for the tooling, it's cheaper in HIT.
Yeah, sure.
HIT. But for the HIT, other issue get cost higher. So then you have a special wafer must be the lifetime of the carrier must be higher. Also use a lot of so-called intensive paste. You pay different from the TOPCon and solar and the PERC. You call it low temperature paste, and it's expensive in the high temperature fired paste, and also other like you also use a TCO, so the target, also another issue for the cost. But all this, once the people get in this industry, more amount of people got in industry, all the drop a lot. And also one key is for the HIT, you can use a very thin wafer. Now in our pilot line we have 130, but now this year we probably go to 110 micron, 110 micron. But typical TOPCon or PERC might be 130, 140, 150. And this will bring cost down a little bit. And also for the paste, as well, the paste is also the key for the cost. They use copper mixed with silver and a new type of paste, and then you can pass all the reliability tests. So no big issue. So get all this you done. So the cost of the solar cell for the HIT can be similar to the TOPCon. And once they have a similar cost, and the people actually want the HIT because they have generated more electricity on the application end. Like
because the bifaciality is higher.
Bifacial, yes, and the lower temperature coefficient, and the lower and the better response for low lights. All this property is better in the TOPCon. It's just two bottles. If the cost the same, you need you get the good one. You have Apple phone. I have another phone, but because I don't buy it because it costs high, right? But the same people now buy Apple phone.
Okay.
The kind of but they quickly drop.
Okay.
So now it's tough to say which one is the final solution for that. But now, of course, TOPCon still enjoy the cost of that.
And the products you have at the moment. So when you compare TOPCon to HJT, so I think how is it from module efficiency and power ratings?
Module efficiency or power rating is similar, same size of for the HIT, we can see like 10 watts, like a two class, 10 watts higher.
Okay.
Typical compared to the TOPCon. Yeah.
Okay. Okay.
So for the HIT, only thing you need to resolve is the cost issue. And now you see the equipment drop also a lot. So a lot of people cut in for this business to the HIT equipment. We have a HIT discuss forum here. So more people focus on pay attention to this business, so can quickly bring everything down.
So we can expect actually HJT costs to come down very quickly soon because so many companies are getting into that. And okay,
the cost may not be the barrier for this type of product.
Okay, that's good to know.
So another one is this HJT can be actually combined with Proswick, called new type of cell, got a tandem cell. That's another benefit for the HJT.
So when you look at put your R&D roadmap actually for cells modules, so how does it look? Okay, so now you still PERC and TOPCon start a little bit HJT. So how are what would you say when is which technology will have the major part of your output?
So now most of our effort on the solar cell side focus on the TOPCon and HIT. Also for the PERC, even it's old product, but now we input a lot of new innovation because, for example, like get a wafer size bigger, and also the wafer not rectangle, not square, a little bit like rectangular. And all the new encapsulation, all the wire technology, to get the space between the solar cell very tiny or even a little bit overlap. So all this small innovation to bring this PERC is still alive, not died. So people still buy. But R&D effort probably migrate to the TOPCon and HIT. TOPCon we have now is called the TOPCon 2. So naturally TOPCon 3, we bring all the new development, new innovation integrated to this TOPCon 3. Most of effort on the back side, so try to thinner the polysilicon on the back side. You can improve your short circuit current a little bit. And on the front side, we already have a selective emitter that bring the VOC high over 730 already. So combine this, so we have a new level of TOPCon, and up to, if we go to the product, maybe another 5 watts or 10 watts higher than the older products. Continue to improve this. And for the HIT, a lot of effort on cutting the costs, test the new wafer, thinner wafer, new type of paste, zero paste, and all the interconnection technology called BP-free, or we call it kind of a smart wire, but a similar idea, but different approach to reach the interconnection. But all this bring down the zero paste consumption a lot, so comparable to the TOPCon and PERC. So we think really the next year you can see the cost of TOPCon and HIT get very close.
And what about you mentioned also that HIT is obviously fits very well with tandem cells. So are you working on that? So how does it look in your technology roadmap?
Early this year we established a post-walk like a laboratory, and not a pilot line, and we do the small cell with integrated with our actually both TOPCon and HIT integrated tandem with the perovskite. It's not like a small scale, like this size. It's not a big wafer size.
Yeah.
So this year, maybe next half year, we created to the single wafer size, like 182 or 210 or whatever, and see if it works. It's still pretty early stage, and far away from go to the manufacturing, mass production.
But how long do you think it will take before we see tandem cell technology seeing mass production? Is it 5 years away or rather 3 or 7?
Tandem cell concept is okay, no problem. It will be verified to really improve the solar cell efficiency. Even our, not a world best, you can create like a 28, 29, and a tandem cell, 29 like efficiency. But the problem comes from the top cell. Is the stability and all other issues. If not resolved, not match for the bottom cell. Bottom cell is you warranty people like 30 years, 25 years. The top one, for example, only work for 5 years. You cannot do that, right? Sure. You get that. So this is how to resolve this materials stability. A lot of university colleges do that. So to be honest, I don't know if that can be resolved. Take how long? Well, year, 1 year, 2 years. Yeah. But the efficiency improve a lot quickly. 10 years.
Sure.
From 3.5% somehow, now it's 25. Singles, not tandem, single junction.
Yeah, it's a reliability question.
Yeah.
So maybe look at finally about other technologies. You know, several of the other companies, big companies, your peers, are trying to become now full solution providers. So they offer batteries, they offer, I don't know, some even offer trackers. So there are also other products that are being offered to simply offer the total solar solution. So what's the strategy of JA?
For JA, actually we are the better for the so-called vertical integration. That on the manufacturing side, yeah, from a wafer to the module, also to a system. This is called vertical integration. But now we have a strategy they call the one body and a two wing. Two wing means one wing is called smart energy, that go to the application side, storage, and also the build up EPC and power station, all this business. Another one, we introduce some key materials for the module, like encapsulation materials, paste, and wire, or junction box, all this small stuff. That's because it's very closely related to our business, right? So we are not somehow do everything. We do related to us, something like that strategy.
Okay.
Yeah, it's not a total solution, key solution, you can call it.
Okay.
So because this materials components we use every day, right? We can do it, and it's not here is the technology barrier, right? You can do it, I can save some cost issue, right? But we don't want to do everything. For example, we don't do glass, we don't do the polysilicon side. So this is still do whatever we can do best. Technologically, R&D side we can support. So we will not bring something we don't know, we don't not familiar, and cut in. That take time and may take money, may not be successful. That's
okay.
Kind of
Yeah, I think that's super. I think focusing on what you can do best is always a
best.
good decision. Thanks so much.
Thank you
it was very nice talking to you.
pleasure.
Thank you.